So we already got the default routing table, which is controlling the path selection. We already got a routing table. In each router, we have a routing table, default routing table. That routing table has got routes for the networks that are within this service provider network. This is service provider autonomous system. To reach between the routers that are inside this autonomous system, we need route. For that, we have enabled OSPF, and the routing table is now having routes showing us the route to reach the networks that are within the service provider domain. That's one control plane that controls the forwarding of traffic for those that are going to those destinations within the autonomous system. That's one control plane. But that control plane is not having information for us to reach between west to east. We don't have routes for packet to get forwarded between west to east. Why? Because the service provider has got nothing to do with the customer's network. So we should not mix. We need a separate routing table, a separate path, separate route maintained in a separate table. You see, what happens is, let me use the paint to make it much clearer. Paint. That routing table has got no information about these customers. That routing table has got only information about those destinations that are within this box. We don't use that same routing table to have routes of the customers. Why? If you have one common routing table for customer and for service provider, two problems will come. One, the customer's security becomes a question. Customer will be in fear. Why? Anytime this provider's network people may enter into our network because they have the route. If these routers have route to reach the customer, sometimes there are chances, service provider spying customer. Customer is not comfortable. So customer want service, but they do not want provider to know about their internal network. So what customer wants? A separate control plane, a separate dedicated path. So when you enable VRF, what actually happens? You can achieve that. So now what happens? According to the customer, west, this is what happens. Customer west thinks that I reach R1 and the next hop is R4, and R4 is connected to my remote office. This is the route information that customer West control plane will have. Customer West control plane will not have routes of service provider networks. It has got the route only to reach customer's local office and remote office. No other routes. There is no routes of other customer network nor the ISP's network. Only the routes of CE West and CE East will be seen in R1's VRF customer E routing table. According to customer E's VRF table in R1, the next hop is not router 2 or router 3. The next hop is this. This is what that VPN that we created. So this is another control plane. We saw in the above one control plane that is for the customer. Sorry, that is for the provider to reach their own network. To provide that VPN service, they need to have reachability between R1 and R4. For that, you have one control plane. This is another control plane that you created using VRF. So this is the control plane for CE West. Now, KFC is another customer. So what KFC feels is, I got an ISP and I am connected to the ISP, and ISP provides me reachability like this. Hey, come on, where are you? So KFC thinks that I'm connected to R1 and R1 is connected to R4, R4 is connected to KFC East. So this is another control plane. But physically, that's not the case. Physically, this is just one router. It's not 3 router. And physically, it's not just 2 router inside the provider. There are many routers. But the control plane provides this isolation. The routing table of a KFC will not have the routes for the CE customers network, nor the routes for the provider's internal network. Likewise, CE routing table, CE control plane has got a separate control towards CE networks. And the control plane, which is default, has got the control for the packet forwarding towards the destination that are within the service provider network. You got 3 separate control plane. According to what the control plane says, the traffic flow or the data plane is going to be. So you got 3 separate control plane. More VRF you create, more control planes you get. We got independent control planes. One control plane is focusing only on the destination that are within the provider network. The other one is focusing only on the destination that is for CE. Another one is focusing only on KFC. See? So, more you create VRF, more control planes you create. More routing tables. Now, because the control planes are separate, I can do this. I can give two customers same IP address, and customer also can have same inside networks. That will not conflict because they got isolation in control plane. So when KFC pings 220.100.100.100, it will only go to KFC East. It will not go to CE East. CE East also got the same IP. But when CE West pings, only then it will go to CE East. The reason is the routing tables, the control plane, the path which is determined for these customers are not the same. VRF helps to achieve this. You need to understand this very well. What is that? ISP is not providing internet service here. They are providing WAN service. WAN service is different from internet service. ISP is allowing you to use their network to talk to your remote office. This is WAN service. When you use ISP to go to Yahoo, Facebook, that is internet service. For that internet service, you need a public IP. For the WAN service, there is no need for public IP. So for this, ISP can give you a private address. ISP may give you one private address, 172.16.01. And here, it can be 192.168. And ISP may give here 172.16.01. Same IP. That won't conflict. And there is no need for public IP here. Why? You're going to come and take the VPN and go to the other end and then go to your office. Why there is need for public address? No needed. Not needed. Not necessary. You are just using WAN connectivity, WAN connection, wide area network. You are just accessing your remote office. So your local office can have 10.0.0.0 subnet, and the branch office internally you may have 172.16, and without NATing you will be able to ping because you are going to go through the VPN. You are not going to talk to the public world. There is no need for NATing in this case. For a normal WAN service, ISP no need to give you a public address. You also no need to get NATed to a public address. You can use your private address, use the VPN, go to the remote PE, and then get delivered to the remote office. Do you have any question? Do you really understand what all I said? Right. So don't wonder if you see a private address on the WAN facing interface. When you see a private address, That may be because you have a VPN, layer 3 VPN. Okay. So in my case, I'm going to repeat the same IP address for KFC and for the customer edge. To prove you that if both the customers have got same IP address, still there won't be a problem. There won't be a problem. Here we are using 200, but just only here I want to use some other network, a private network, 172.16.0.0/16. But if you see the loopbacks of East KFC and loopback of East CE is the same. And the WAN IP address as well as the loopback of West is same. And I'm going to successfully ping these address without conflicting. When I ping from KFC, it will only ping the KFC's remote office, not the customer edge remote. It is all because of two things. One, locally to differentiate, you got route distinguisher. To say this traffic is coming from west, that is route distinguisher. And if it is coming from west, this is the route target that you should use inside the VPN. Okay, I'll use the route target correctly, so that I will only be delivered to C East, not KFC East. So inside this tunnel, as I said in the previous class, route targets helps to differentiate. If the route target for west is 1:1 and route target for KFC West is 2:2, when you ping from here and here, this address 220.100.100.100, you know how the packet will go? The packet that is going from the KFC West will be like this: 220.100.100.100 2:2. This whole thing is seen as the address. When you ping from here, it will be 220.100.100.100 1:1. This whole 96-bit is seen as the destination. So 2:2 means it is for the East KFC. 1:1 is for the West, East CE. Without any problem, it's going. It is not just seeing the 32-bit address and Monday Sori Jigite. No Monday Sori. Because it has got another 64-bit to differentiate, saying this is from KFC, this is from CE, this is from KFC. 32-bit address plus 64-bit route target, totally 96-bit. Did you understand? Okay. Now we are going to do this. Here we had BGP in the previous class. So you saw easily BGP, and the VPN is also BGP. So without any redistribution, manual redistribution, automatically the redistribution happened in the previous class. Did you see me redistributing? No. VPN is a BGP. Customer is also giving using BGP. So they went very well. But this time it is not going to be that easy, because this customer KFC is allergic to BGP. they have more affinity towards OSPF. He says, we don't want BGP, my dear, I want only OSPF. ISP will not say, no, we are also inside using OSPF. You cannot use OSPF. No, ISP can't say that. ISP will say, oh, no problem, man. You can use OSPF. We know how to keep my OSPF route separate from your OSPF route that is coming. We know how to do it. So you can have OSPF. And this side of the KFC says, we will use EIGRP. We don't want OSPF or BGP. We want EIGRP. East or West, EIGRP is the best. And our autonomous system is 100. But the VPN is made out of BGP. How the OSPF route will enter into this VPN and get into EIGRP? We are going to see all these things. Okay. Before we go that far, I want to tell you one more thing. I told you, but you might have forgotten. I think someone is having question. Ask question. Someone is trying to ask question. Who is that? Ask. Yes, that is what called as WAN connection. This is not for internet. This is for communication between branch office to head office to head office, branch office to branch office without any natting, using just their own private address. Fine. So WAN, for the WAN connectivity, we use layer 3 VPN. See, we can also include internet. That is what I was expecting as a question from his mouth, but till that end he did not use that word. So I was wondering what he's asking. There is only two things. One is having multiple site. That is what I'm talking. If he is talking about multiple site, then he did not understand the class. That made me to talk this long. Only two things we can do with this. One, having connectivity to your branch office. The other one, having connectivity to branch office as well as go to the head office to go to the internet. These are the two things we can do. He did not ask me about this. And he is talking about something which has already been explained. He's asking, he's not talking, he's asking a question about the things which I'm already explaining. That made me to think in a different way. Fine. Now, where are we? We are going to see the step-by-step approach now. Though it was very easy, step-by-step. If you would have gone through yesterday's video, you would have got the very clear steps. First, what I did IBGP between these two routers. Is it difficult to form IBGP? Answer. That's the first step we did. It is not difficult at all. We were an expert. We learned BGP thoroughly. We are an expert of BGP now. All right. So that is the first thing. We formed IBGP using loopback. That was the very first step. And if you want me to write down the commands for that, I can write it down. What do you do? Router BGP 100. Neighbor 4.4.4.4 remote AS 100. Neighbor 4.4.4.4 update source loopback 0. At last, the VPN command. What do we say? Address family VPN v4 unicast neighbor 4.4.4.4 activate. This is the very first step. Do similar configuration on R4. In that, what will be the neighbor address? 1.1.1.1. Is this step clear? This will bring the VPN up. VPN story is over. VPN has come up when you put this command. Provided you have reachability between this loopback to loopback. Very important. See, we already have MPLS. That you don't forget. We already have OSPF and all routers. Loopback is used as the router ID both by OSPF and MPLS. Now we formed IBGP, which is also using that same loopback address as the router ID and forming an IBGP session. These two lines. Using that IBGP session, we negotiate VPN v4 by just putting active command. That's all. VPN is up. Now, there is no other work for VPN. VPN story is over. The tunnel is ready. Question. Do I have BGP in this two router? Someone answer. No need. You should not. Fine. What is the next step? I'm going to erase this because I don't have space. What is the next step? Next step is you need to create VRF. VRF for each customer, meaning control plane. A separate logical topology will be built when you build the control plane. I already explained those three topologies that will be achieved by the end of this lab. Control planes. So we create a VRF here. For this, we create a VRF. Command is IP VRF. You can give any name. You can give this also as a name. CE-West. Likewise, I'm going to create another VRF. IP VRF. KFC West. Okay. We create two VRF, but this is not actually going to give you two separate routing table. Why? It needs an ID. Each routing table needs an ID. This name CE West, KFC West cannot be used as an ID. We call that ID as route distinguisher, RD. That's the command. I'm going to say for CE 1:1. For KFC, I'm going to say 2:2. You cannot give same route distinguisher on this router. You can use the same route distinguisher on another router for different customer. But on the same router, you cannot use the same route distinguisher for different customer. It should be different. Now, RD is given. That is to differentiate this customer routes locally. But over the VPN, to differentiate, you need RT, route target. It has got two parts, import and export. For now, we will keep both import and export same thing. I'll call this as 11:11, 12:12. So all that is going from KFC will be appended with 12:12. All the packets that is going from CE will be appended with 11:11. That is how inside the tunnel the routes are going to be differentiated. Now after putting this 3 line, come out of it. Your VRF is almost ready, but only one more thing is left. What is that? You need to tell which interface will be the member of VRF CE West and which interface will be the member of VRF KFC. That you go under the interface and say this command, IPVRF forwarding KFC West. That makes this interface as a member of KFC control plane. So that whatever this guy advertises will be learned in that routing table. Likewise, you go under F01 and say IPVRF forwarding CE West. That is how we make membership to the VRF. Right? So far good? Do the similar configuration on R4. What is next? Next is getting the routes from the customer into the customer's routing table. Customer's route, customer will be advertising. That you need to receive it on the correct routing table. Right now we have 3 routing tables. One is KFC West routing table, another one is CE West routing table, another one is global routing table. So when KFC is advertising this network, it should be learned in the KFC's routing table. When CE West advertises this network, that should be learned inside the routing table of CE West. How is that possible? If you use BGP, it will come automatically. You use BGP 10 here, and here it is BGP 100. So what you do is, you go under BGP, I repeat, when customer is also having BGP, what you are going to do is, you are going to go under BGP in the provider side, under BGP, go under address family. But not VPN v4, IPv4. VRF CE West. What is that meaning? You go under the control plane of CE West in BGP and say, I got a neighbor 100.0.0.10. Sorry, 1. 100.0.0.1. That is the IP address of this. You see, 1.1. So you say, I have a neighbor in remote AS10 with this address. So what it will do, this router will use the routing table of CE West, which is connected to this link, and try to form neighbor. See, the neighbor statement is not under global BGP. It is under the control plane of CE West BGP. Yes. Neighbor is, listen, where I am configuring this, tell me. R1. For R1, who is the neighbor? 1 only, no? This is 1. You see, I have written here. Yeah. Nice. This is how we should ask straight question. Anbu, you saw the example? Straight question. How nice it is to ask like this. Now, so in BGP, it is very easy. This will give root. This will give root, and it will be learned in the VRF of C West, and it will go through the VPN, and it will get accumulated in CE East VRF, and from here it will be advertised because this is also BGP. There is no problem. Up to this one we did in the previous class. Only this much configuration I did and it was working. Nothing more. Now, sorry, your question, yes. Yes. Inside the interface. See, after you, very good. See, after we go inside the interface F01, you say what? The very first question is IP, VRF, forwarding for what? C West, you said no. And then you should give this IP address, correct? IP address 100.0.0.10, 255.0.0.0. This is interface configuration, no shutdown. Yep, but this is under BGP. That's right, Dash. What you said is right. Okay, so we did only this much, and we were able to ping from the west to the east. Only these many steps. But when it is different protocol on the customer side, there is a need for a redistribution. Why? Because BGP is what we use in tunnel, but customer is using different protocol. So you have to take from that protocol and redistribute so that BGP can carry it. All right, so here OSPF and here EIGRP. We are going to have this as the setup, and we are going to learn first through OSPF. Remember what I am saying now. We are going to do this lab in the next class, but remember what I am saying now. This router is already running OSPF. Now if you create another OSPF, it should have another process ID. Can't use the same process ID. Okay, so you create another OSPF for the VRF KFC with different process ID. If you would have said OSPF 1 earlier, process ID 1, now you should use 2. For each OSPF, there will be separate router ID, separate process. So you form a neighbor between these two using OSPF now. Afterwards, go under BGP, address family, IPv4, VRF, KFC, and say redistribute OSPF. OSPF. We'll be seeing these things in our next class. Similarly, here EIGRP. When you do these things correctly, from OSPF to BGP and BGP to OSPF redistribution, EIGRP to BGP and BGP to EIGRP redistribution, these two also can ping. At last we'll do testing like trace, ping, all those stuff, right? So